Welcome back mobile communication lecture series session 9. In the before session we have already discussed improving system capacity based on cell splitting model. In this session we are going to see about the topic is cell sectoring. What is cell sectoring? Why we use for cell sectoring in your mobile communications? The definition of sectoring is the techniques for decreasing the code channel interference and thus increasing system capacity by using directional antenna is called sectoring. So here we go using directional antenna. It connects the edges of the cells. The factor by which the code channel interference is reduced depends on the amount of sectoring used. Improving SI based on sectoring. The idea behind using the directional antenna is the reduction in code channel interference and thus increasing the system performance, which results by focusing the radio propagation only in a particular direction where it is required. So in this figure clearly explained 120 degree sectoring and the another one for 60 degree sectoring. The 120 degree sectoring, here we go using in your cell will be divided into 3 parts. 1, 2, 3. 3 sector is available in the 120 degree sectoring. And the next one for 60 degree sectoring, the overall 360 area will be divided into 6 parts. 1, 2, 3, 4, 5, 6. 360 divided by 60, the value is 6. So 60 degree sectoring in your overall cell will be divided into 6 parts. The area covered by each directional antenna is called as a section or sector. The factor by which the code channel interference is reduced depends upon the amount of sectoring used. A cell is normally partitioned into 3 120 degree sectors is indicated for figure A and the another one for 6 60 degree sectors is indicated for B. Improves SI. SI is signal to interference ratio based on in your sectoring. In this figure explain how 120 degree sectoring reduces interference from code channel cells. The out of 6 code channels in the first tier, only 2 of them interfere with the center cell. If omnidirectional antenna were used at each base station, all 6 co-channel cells would interfere with center cell. Because of this, SI has been increased from 17 dB to 24.2 dB. This SI improvement allows the wireless engineer to decrease the cluster size and in order to improve the frequency reuse, which improve the system capacity. Here I mentioned some disadvantage of sectoring. The first one, each sector is nothing but a new cell with a different shape because channels have to be partitioned between the different sector of a cell. And the next one, sectoring reduces the coverage area of a particular group of channel, which results in more number of handoff. And third one, decrease the trunking efficiency. And then fourth one, in an urban area the directional antenna patterns are somehow ineffective in controlling the radio propagations. These are all the some disadvantage available in your sectoring. And the next two topics, a novel microcell zone concept. Why we go for microcell zone concept in your mobile communications? So it is connected 3 different type of zone in a single cell. Zone site are connected to a single base station and share the same radio equipment. The zones are connected by coaxial cable or fiber optic cable or microwave link to the base stations. The multiple zones or single base station make up a cell. As a mobile, travels within the cell, it is served by the zone with the strongest signal. This technique is particularly useful along highway or along urban traffic areas. This approach is superior to sectoring since antennas are placed at the outer edge of the cell and any base station channel may be assigned to any zone by the base station. In comparison with sectoring, the number of hand be reduced in this method. So this is the general concept of microcell. So here I mention the outer area coverage. It's based on in your cell. In the cell, it consists of three different type of zones. The zones are connected within your transmitter or receiver. All the cells will be connected to zone selected based on in your microwave or haptic link, and the next the all are connected to single base stations. So this is the general diagram or general concept of in your microcell zone concept. Microcell zone concept. All three zone sites act as a receiver for signal transmitted by a mobile terminal. The BS terminates which of the zone site has the best reception from the mobile and uses the zone site to transmit the signal on the downlink. The zones are connected by a coaxial cable, fiber optic cable or microwave link. As a mobile travels from one zone to another within the cell, it retains the same channel. The base station simply switches the channel to another zone site. A given channel is active only in the particular zone in which the mobile is traveling, and hence the base station radiation is localized and an interference gets reduced. What are the advantages of microcell concept? So here I mentioned some advantages. CCA, it is a co-channel interference in the cellular system, is reduced since a large central base station is replaced by a several low power transmitters on the edges of the cell. To decrease co-channel interference, improve the signal qualities, and also it will increase the channel capacity without decaying the trunking efficiency which may caused by sectoring. So these are all some advantages available in your microcell concept. Thank you.